Chapter 11, 4, limits at infinity. Limits of infinity. If r is a positive real number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes? Then the limit as x approaches infinity of 1 over x to the r, 1 over x squared, 1 over x cubed, 1 over x to the fourth is equal to 0. Why is that? Because if I take 1 over 2, that gives me 1/2. 1 over 4, 1/4, which is 0.25. Which one's smaller, the 1/2 or the 1/4? 1/4. So what you're saying, the bigger the number in the denominator, the smaller the fraction is, right? So I'm going to have 1 over 100th, 1 over 1,000th, 1 over 1,000,000th, right? So that means it's going to get eventually so small that it's going to appear that it's close to what value? It's going to appear as though it is the value 0. Do we understand that? Yes? Does that make sense? Okay? If x to the r is defined when x is less than 0, then the limit as x approaches negative infinity is still going to be exactly the same concept. It's still going to be what value? 0. Do we understand that, yes or no? For real? Okay. The limit as x approaches infinity of 4 minus 3 over x squared. Okay, what I want your brain to do is I want your brain to always go back to this concept right here. So we want it to become a fraction as much as we possibly can. Why? Because we know that that fraction, as x gets really big or as x gets really small, approaches what value every time? 0. So if we look at this right here, this limit, okay, what I'm going to do is I'm going to break this up, and I'm going to write this as the limit as x approaches infinity of 4 minus the limit as x approaches infinity of 3 over x squared. Correct? Well, what is the limit of 3 over x squared going to approach? 0. Correct? Do we all understand that? This whole thing is going to become 0. And what is the limit of 4? 4. So I'm going to have 4 minus 0, which gives me 4. In other words, the limit of this function, as x gets really, really big, is going to approach the value 4. Do we understand that, yes or no? How does that all cancel out like that? Well, if you apply this concept right here, I have a number over x squared, yes? And that's going to approach 0. Okay, so that is why this right here actually turns out to be 0. Does that make sense? Okay? And the limit of 4 is just 4 because there's no x to plug anything into. Does that make sense? Which is why 4 minus 0 gives me 4. Any questions over that? Well, it's really great when we can write it as two separate things like that. However, when we have a problem that looks like this, it's not so easily done. Okay? It's not so easily done because I can't separate into so many fractions. Do we get that? So the way we're going to do this is everybody write that down for me. I want you to look at your denominator. And in your denominator, find the variable with the highest exponent. And that's going to be, in this case, x squared. And what we're going to do is we're going to divide each term by that. Okay? So step 1, you are going to find the variable with the highest exponent in the denominator. Step 2, you are going to take and divide each single term by that. Do we understand that? Each single term in the top and each single term in the denominator. Okay? So this is going to be the limit as x approaches infinity of negative 2x over x squared plus 3 over x squared all over 3x squared over x squared plus 1 over x squared. And the reason why we're doing this is because we want to utilize that property that I just taught you at the very beginning, which is 1 over x approaches what value? 0 as x gets really big or as x gets really small. Does that make sense? Yes or no? Because you have to take the highest exponent so you can get things to cancel out. If you don't take the highest exponent, things will not cancel out so you can get numbers. And I'll show you that here in a moment. We ready? Okay, so what we're going to do is we're going to go ahead and we are going to simplify this. So this gives me the limit as x approaches infinity. What's negative 2x over x squared cancel down to? Negative 2 over x plus 3 over x squared, all over the x squareds cancel out, 3 plus 1 over x squared. Okay? Do we all see that, yes or no? Okay, so now with that said, tell me, what does negative 2 over x approach when x gets really big? Come on, use that property. What's negative 2 over x approach? As x gets really, really big, what is that going to become? It's going to be 0. Why is that? Because this is negative 2 over infinity. Well, what is that? That's a really, 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 really small number, right? Doesn't matter. No, we're not guessing. What are you doing in your head here? You're plugging in your head. It doesn't matter. It doesn't matter what you're plugging in, folks. This is what you're doing in your head. What does negative 2 over infinity approach? This is the biggest number you can possibly think of, isn't it? And it's in the denominator. The bigger the denominator number is, the closer it gets to what value? 0. So this turns into 0, this turns into 0, and this turns into 0. So what I have is going to be 0 plus 0 over 3 plus 0, which is going to give me 0. So this thing approaches 0 as it gets really, 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 really big. Do we understand that? Why do you what? Okay. Let's try this example and you'll understand, I think, a little bit better. It is not the same one. Look closer. It's squared in the top. So write it down again. Because it's going to give you a different answer. Just write it down, promise. Just. Okay, what am I doing? Step 1, look in where? The denominator. What is my highest variable with the highest exponent, I should say? So in my denominator, what I'm looking at is going to be x squared. So I'm going to take the limit as x approaches infinity. Does it matter if it's negative infinity or infinity? Not in this case, does it? That's going to be negative 2x squared over x squared plus 3 over x squared all over 3x squared over x squared plus 1 over x squared. We found the variable with the highest exponent in the denominator, and now we're going to divide each and every term by that, correct? Okay, so what does x squared over x squared turn out to be? What's x squared and x squared? What's that cancel out to give you? Times 1, which is just negative 2. What's going to be this? 3 over x squared stays. Over here, what happens? The x squareds cancel out, and I'm left with 3 plus, and then this is 1 over x squared. So what happens to this right here? What does that turn into? That turns into a 0, and this turns into a 0. So what is my limit going to approach? Negative 2/3. Negative 2/3. As x gets really big, it's going to approach negative 2/3. Do we understand that? Maybe with an exponent in the denominator. Like this right here? Yes, because if I'm squaring a number, let's say my number is 4, and I square that gives me 16. Sure, doesn't matter. Yeah. Anytime you have a variable in the denominator, it's going to approach zero. It's going to approach 0. Okay, it looks like the same problem, but it's not. Please write it down again. That wasn't so hard, was it? Okay, same concept. So what's my denominator value I'm going to divide by? X squared. Denominator. In the denominator, what is my variable that I'm looking at? Devin, are you with me? Okay, so I have the limit as x approaches infinity of negative 2x cubed over x squared plus 3 over x squared all over 3x squared over x squared plus 1 over x squared. So this is going to be the limit as x approaches infinity. What happens to my x cubed over x squared? So I'm going to be left with negative 2x plus 3 over x squared all over, those cancel out, 3 plus 1 over x squared. Okay, well, let's look at this a minute. What happens? What does this fraction 3 over x squared become? And this becomes 0. So what I have is negative 2x over 3, correct? Yes? Okay, well now, as x gets really big, what's happening? So the numerator is approaching negative infinity. Why? Because that negative's there. And the denominator is approaching what? 3. Well, how's that possible? The limit does not exist. Because the numerator is approaching negative infinity without bound, and the bottom is approaching 3. Since those limits do not match, it does not exist. It does not exist. Do we understand that? Okay. Now, I decided against a worksheet because I felt if I was teaching it like the book was teaching it, it would be better for me to give problems straight from the book so that you could check your answers in the back of the book. Agree? So what I've decided to do to give you for homework tonight is going to be chapter 11.4, 5 through 21 odd. I gave you the odds so that you guys could check your answers in the back of the book. I mean, it is not difficult. It is doing exactly what I just showed you, okay? 5 through 22, it says find the limit if it exists. If the limit does not exist, explain why. Use the graphing utility to verify your results graphically. So all you're doing is exactly what I've just been showing you. Now, if you have something that looks like this, what should you do to that denominator? I would FOIL that. The limit as x approaches infinity of 2x squared minus 6 all over x squared minus 2x plus 1. Do we all see that? Then do you know what your denominator is of highest degree? X squared. Now can you calculate this? Sure, that's the limit as x approaches infinity of 2x squared over x squared minus 6 over x squared over x squared minus 2 over x squared plus 1. This becomes a 0, that becomes a 0. This becomes a 1. This becomes a 2. So I have 2 minus 0 all over 1 minus 0 plus a 1. What's x squared divided by x squared? No, because you're reducing it. Okay? So 2 minus 0 is 2. 1 plus 1 is 2. So what does this approach? It approaches 1. Okay? This was number 18. That's the one I did. You guys have the rest of the period to work on tonight's homework. What are you dividing by? Yeah, there is. It's the power of 1. If you look at this problem right here of number 8, what are you going to divide by? What's my denominator? X to the first, right? So I have 1 over x minus 6x over x all over 1 over x plus 5x over x. So this is going to give me 1 over x minus 6 all over 1 over x plus 5. What does 1 over x approach? Minus 6 all over, what does 1 over x approach? Plus 5, which approaches negative 6 over 5. What does x over x reduce down to? Yep. Make sure you're checking your answers in the back of the book as you do them.